This is lesson number 3, pair of linear equations in two variables. In this lesson, we are going to study the following points. First one, linear equation in two variables. Second one, simultaneous linear equations in two variables. Third one, method of solving linear equations. First one is the graphical method, second is the algebraic method. Equations reducible to a pair of linear equations in two variables. All these 4 points we are going to study in this lesson. Let us see one by one. First one, linear equation in two variables. An equation of the form ax plus by plus c equal to 0, where a, b, c are real numbers and a and b should not be equal to 0 and x, y are the variables, is called a linear equation in two variables x and y. Just see, the heading is linear. That means degree is supposed to be 1. Equation means equal to sign, right? See here equal to sign is there. And in two variables. So x and y are the two variables. Correct. So that's the reason we are calling it as the linear equation in two variables. And this one is the standard format of the linear equation in two variables. The condition you have to remember, what is that? A and b should not be equal to 0. If a will become 0, imagine a is 0. That means this term will become 0. An equation will be only in one variable which we don't want. That's the reason what we said. A and b should not be equal to 0. Correct? Now let us say this one here. Here x plus y which is equal to 3. Two variables are there. Degree of this equation is 1. Even the equal to sign is there. That's the reason we are calling it as linear equation in two variables. Same here, look at the second equation also. 2x plus 3y equal to 7. Right? As I said, linear equation. That's the reason degree is 1. Okay. And graph of any linear equation in two variables is always a straight line. You can see in the graph paper here. The linear equation graph is always a straight line. Right? Come to the another point now. Simultaneous linear equations in two variables. A pair of linear equations in two variables is said to form a system of simultaneous linear equations. Simply what? A pair of linear equations. Together we are calling it as the simultaneous linear equations, or we can say system of simultaneous linear equations. Right? Two equations together. Here, this one is first equation, this is the second equation. This is the standard form of linear equations in two variables. Okay, here a1x plus b1y plus c1 equal to 0. a2x plus b2y plus c2, this is supposed to be 2. c2 equal to 0. This is the standard form of writing the linear equations, where all these coefficients a1, a2, b1, b2, c1, c2 are the real numbers, such that a1 square plus b1 square should not be equal to 0. a2 square plus b2 square should not be equal to 0. Right? You don't have to worry too much about this one. Just simply you see, look at this equation and this equation. Correct? Here all coefficients are present. X and y two variables are present. Equal to sign is present. So these two equations, I can call them as the simultaneous linear equations in two variables, right? Or I can call these two equations as the system of simultaneous linear equations. Correct? Come to the next point now. Method of solving simultaneous linear equations. There are two methods. Out of that, first method is what? Graphical method. In this graphical method, there are three cases. Look at the first one here. First graph you just see. I have two equations. So definitely I'll get two graphs. You can say two lines on the graph paper. Okay. This is for P for the first equation and Q for the second equation. I have just named the lines. That's all. Now looking at the line, easily you can make out the lines are intersecting lines. Correct. As they are intersecting, they are having only one common point. So here at this place only one common point is there. That means only one solution is there. Right? So here exactly one solution. at least one solution is there for the lines, it means that lines are consistent. Okay, try to understand it. I said at least one solution, that means more than one solutions are there, then also lines are consistent. Okay, now come to the second one here. Now both the lines, line P and Q, they are overlapping lines, or we can say these lines are coincident lines. Here each and every point is common for both the lines. It means that these two lines have infinitely many solutions. Okay, as infinitely many solutions means what? Lines are consistent. Now whenever each and every solution is common for both the lines, so lines are called as the dependent lines. Okay, now remember, whenever the coincident lines are there, those lines are dependent lines. Fine. Come to the third one here. Looking at this one, P and Q, these lines are parallel lines. As they are parallel, they are not going to meet each other at any point. That's the reason they are not sharing any point. So, no solution. And as they don't have any common point, we can call them as the inconsistent. Okay, right. See here the last point. Consistent lines means they should have at least one solution. That already I told you. Okay, let us see the another point. Method of solving simultaneous linear equations. Second method is algebraic method. Okay, in this method we can solve a pair of simultaneous linear equations in three ways. First one, substitution method, then elimination method, and then cross multiplication method. In all the three methods you will get the same solution, only the ways are different. Okay, come to the next point here. Interpretation of the pair of equations. It means that as soon as you will look at the pair of linear equations and their coefficients, immediately you will come to know whether the lines are intersecting or parallel or coincident. Okay, see here. We are having two equations here in the standard format. We know the coefficients also, a1, b1, c1, a2, b2 and c2. So here we will do the ratio comparison. Okay, so a1 by a2, if they are not equal to b1 by b2, then the lines are intersecting lines. Immediately you can make out that one. As the lines are intersecting, what was that? Unique solution. And as single point is common, then that means what? Lines are consistent. Correct, na? Imagine you are having this equation here. 2x plus 3y plus 2 equal to 0. And another equation is maybe 2x plus 4y, which is equal, plus, here I'll write down once again 2, which is equal to 0. See, 2 by 2, which is equal to 3 by 4. Are they equal? No, they are not equal. It means that definitely these two lines are what? Intersecting lines. Fine. Looking at just the coefficients and their ratio. Come to the second one here. Look at this one. All three ratios are equal. All three ratios are what I said? Equal. As they are equal, so definitely the lines are what? Coincident lines. Right? That means overlapping lines. As they are overlapping lines, they have infinitely many solutions because each and every point is common for them. As they have infinitely many solutions, lines are consistent. Let us see the other one here. Suppose I write down 4x, then 6y plus 4 equal to 0. Now look at the ratio, 2 by 4. This one is 2 by 4. So ratio will become 1 by 2. 3 by 6. Ratio is 1 by 2. And here 2 by 4. Ratio is 1 by 2. Correct? See here. Ratio is here 1 by 2. All the ratios are equal. As all the ratios are equal, what I said here? Lines are coincident lines. Right? Now come to the other one now. The third one. I'll just remove this one from here. Now first two ratios are equal, but third one is not equal. See here, third one is not equal. So here at this place, look at the example here. I write down 3, which is equal to 0. First two ratios you see, 2 by 4, that means 1 by 2. 3 by 6 means 1 by 2. And this one is 2 by 3. So all the 3 ratios are not equal here. Here I wrote 1 by 2, which is equal to 1 by 2, which is equal to 2 by 3. The third one is not equal. That means lines are what? Parallel lines. As parallel lines, no common point. That means no solution. Right? That means lines are inconsistent lines. So looking at just the coefficients and their ratios, immediately we can make out which type of lines these are and how many solutions they have and whether the lines are consistent or not. Okay, for that what you need to remember? You need to remember this one. This condition, and this condition you need to remember. Okay, come to the next one. Equations reducible to a pair of linear equations in two variables. There are some pair of equations which are not linear to start with, but can be reduced to the linear form by substitution. Now look at this one. The equations are looking like this way. Now in this case, what we are going to do here, we can convert this type of equations in the form of this standard format. For that we'll consider, let 1 by x equal to m and 1 by y which is equal to n. See here, at this place a is there and divided by x is there. That means 1 by x. So instead of 1 by x, what we are going to write down? M plus b is there and then y is there at the denominator. So 1 by y means what? N, and then which is equal to c. So we brought our equation in the standard format here. Correct? So look at this one, this equation I have written here. It can be easily solved by any of the method of solving linear equations. Once the equation comes in the standard form, we are able to solve that equation. Right? It means that we can reduce that linear equation in the linear format. I hope all of you have understood this introduction. Thank you.